Hello, Matthew Franxman, Thomas Gnadinger, and speaking, Owen Tucker. Here today to talk to you about engineering better medicines. The problem lies mainly in today's medicines, specifically our antibiotics. These are becoming more and more ineffective at fighting the diseases they were designed to prevent. The bacteria continue to get better at fighting our antibiotics through time and overuse. Doctors have played a large role in this becoming a problem today. They often give out medicine indiscriminately regardless of what they know about the illness. Using antibiotics as a diagnostic like this allows more and more bacteria to be exposed to the medicine. All of this leads to the bacteria eventually developing more immunity. Doctors aren't the only problem facing the antibiotic industry today. These cows seem to have a beef with humanity, and they want to put us on a stake. Literally. The problem here is black and white. Farmers are milking their livestock's immune systems dry. Just as antibiotics are overused in humans, the same happens on a farm. Farmers use the same antibiotics as doctors, but on a much larger scale. 80% of antibiotics are used by farmers. This causes, once again, the normal bacteria to die while leaving the mutated resistant bacteria alive to reproduce and pass down mutations to future generations. While you may not know it, you could be part of the problem. Many consumers buy soaps and cleaning products with antibiotics in them, as they have been told that it would keep them and their families more healthy. This could not be less true. These products are often unnecessary and usually harmful. The FDA has banned 19 chemicals used in over-the-counter antibacterial products for this very reason. Now, here to talk to you about our solutions to this grand engineering challenge is Matthew Franxman.
Now that we have identified the problem, how do we solve it? We have developed 3 potential solutions that may help fix it. The first method is finding new ways to kill bacteria. Currently, scientists use antibiotics to either kill bacteria or destroy their means of reproduction. However, the bacteria are mutating to become immune to our drugs. Therefore, we must develop new ways to kill them and put more time and money into research. However, this is not a long-term solution to our problem, so we're going to have to look for other means. Another solution would be to give livestock different antibiotics. As mentioned before, livestock use the same antibiotics we do, giving bacteria more exposure, allowing them to become more resistant. To fix this, we would need to develop new, different medicines for livestock to limit the bacteria's exposure. However, like before, this can only be used as a short-term solution because bacteria, again, would become more resistant over time. A more permanent solution would be to make humans more resistant to bacteria and some viruses, maybe even immune. Our means of doing this would be through the use of CRISPRs, or clustered regularly interspaced short palindromic repeats. This process uses the Cas9 protein to identify strands of DNA to replace with new, programmed strands. These new strands of DNA would contain the information of all known diseases, rendering us effectively immune. This process works similar to how we become immune after fighting a disease, with our DNA memorizing the strand and prohibiting it from returning. However, this raises a moral issue on whether or not we can change our genetics, and if we should even partake in this endeavor. And that wraps up our presentation. Thank you to everybody for watching. Have a wonderful day. Stay healthy.